Okay, so before we get started, I'll just a couple of other bits of administrivia. This is going to be the root server session in here. So we're going to be talking about basically Unix-based root servers, to some extent how they're deployed at exchanges, but also just generally. And if you're interested, so this is not the NSP SecBof, that's in the room next door, that way.
Yeah, I'll go that way.
Through that wall, yeah, run. Okay, and then the other thing is downstairs on the 4th floor, so it's not on the same floor as here, but downstairs there's the, we're calling it like the vendor collaboration suite, but everybody's like, what the hell's that? What the hell's that about? Is it like where the vendors go to hang out and collaborate about how much they can get more money out of us? Well, actually, it's not. What we've got down there is the guys from Comcast and a couple of other vendors. They've got some end-to-end V6 native dual stack stuff. So if you remember the demo that they did in Philadelphia, this is an evolution of that. They've got some more vendors involved. There's some demonstration of both V4 and V6 server load balancing as well. So that's using some pretty new appliances to do that. So that's downstairs on the floor below. It's down the escalators, basically. So do go visit them during things like coffee breaks and that kind of stuff. I think they're wrapping up down there for now. Okay, so we'll get started. Our first speaker today is Elisa Jasinska from AMS-IX and Chris from Switch and Data. And is Chris going to do the talking, or are you going to do the talking? You're both going. It's a double act, right? They're going to talk about some testing that they did over at actually at the LINX and just generally a few months ago. Actually doing some performance testing of root servers and related to the issues that have been seen, particularly in some of the bigger IXs.
Okay.
It'd be nice. She's lost her voice.
I've lost my voice, exactly, so I apologize for maybe not being able to speak very clearly. All right, so we're actually going to start out with a little bit of a general overview because I'm not sure how many people here actually know what a route server is supposed to do or be, because this is more of a topic actually important for internet exchanges at that time, where, yeah, Chris and I both work at internet exchanges, so we've been busy with this. So what we're going to do is first tell you a little bit why do people actually want route servers, what do they do, and how are they useful to us, and then a little more on technical details, what do they have to fulfill to actually make sense and work in a fashion that so they provide what we want from them. And then we're going to go to the interesting part where we're going to present on the current open source implementations that are out there that incorporate route server functionalities. 3 of them. Yeah, nothing more than those 3 actually. And the working group that we've been active in, so to speak, that was busy with testing those 3 implementations and trying to figure out where they have their limits, how they scale, how they function, do they function. And on that, we're going to have some shiny graphs and test results and things we've figured out at that time. All right, so let's start out why. Why do we want route servers? So as I said, internet exchanges, a peering platform where lots of parties interconnect and want to peer with each other. And we use them within that peering platform to make it easier on people to actually exchange their routes with each other. And the general issue is that if you are in an exchange point and you have an open peering policy, you want to peer with as many parties as possible, which creates a lot of overhead for you with maintaining all those sessions, configuring them all, doing all the shit to keep them up. Should I just say shit? It's fine. Okay. Good, Chris. Thank you. You talk into a mic when you talk, then it's gonna. Okay. Okay, so what you can do with a route server is it's like a transparent BGP node in the middle of your platform, basically, and you set up one session to it, and it transparently forwards everything that it receives from that one session to every other party connected. So what you can do is you reach a lot of parties with only one session being at that exchange point. It helps you in cases like if you still, I mean, obviously you still probably want to have all your biggest peers under your control and directly have sessions established with them. It helps you if that session dies for whatever reason, you still have the route server where you receive basically the same prefixes from for redundancy purposes. Or in the other way around, in case the route server dies, you still have a direct session to another peer that will still give you the same prefixes again. So you can use it for redundancy at exchange points, or when you get into an internet exchange, the first thing you can do is set up a session to a route server, which will immediately give you a lot of prefixes already and not take you all that overhead of spending weeks on emailing everyone, telling them, I want to peer with all of you. So this is like the global overview. What can we do with route servers? All clear so far? Everyone is typing away anyways, so I'm not quite sure. All right, so what do they do? A little more details. Everyone here speaks BGP, right? So it looks like BGP. We receive normal updates. Now, I don't have anything I can point at here, but I'm just gonna, do I have something to point at here? I'm just gonna talk about it. So let's say we have a route server set up at the .1, and now everyone sees where the IP address is, where the packet, that update went to, right? Oh, I can just do this, cool. Huh?
Awesome. It is on every screen.
On every screen, cool.
You can see your hand.
Wait, that doesn't work. All right, so we have a route server on 10.23.0.1, and we have another peer connected to it, .5, and another one, .4. And those, both of them send me a normal BGP update to the route server announcing their prefix. In the first case, the .5 sends me the route to 2.0.5, and that somehow skipped slides. And .4 sends me down here the route to 2.0.4/24. So what the route server now does with that, it applies a whole bunch of filters because people still may want to decide, even though they can receive all those prefixes from that one route server, they still may want to decide if they want to peer with a certain party or not. So we can configure filters on what we want to receive and who we want to announce stuff to. And after doing that, it creates sorry. It performs its best path selection, puts in all the prefixes or all the best paths into the RIP for each single peer. Why it has to do that for each single peer is related to the filtering. So let's assume that one person doesn't want to have routes from one specific AS, but in the global best path selection, that prefix would actually show up as the best one, going over an AS that someone else may have blocked. So the problem is, in a normal case, he would not receive that prefix at all because we don't have add path yet, so he wouldn't get something like a second choice or multiple choices. So he would be lost on that one prefix completely. So what route servers do is they maintain a RIP per peer they have connected and do a best path selection for every single peer, taking into account their filtering options and what they would like to receive or not receive. So we build a RIP for that peer, and what we then do is the route server basically forwards exactly the same route that it already received to every single participant. In our case, where we only have 2 peers and 2 routes, it would forward the route from we previously received from .5, 2.0.5 to peer.4, and it would forward the 2.0.4 to peer.5. Taking into account that the route server itself is completely transparent, so it does not insert anything into the AS path. This is still exactly the same as it has been received, and doesn't change any next hops or anything. It just forwards it as it is, the information down to all the other peers. Right? All good? So far? Okay. So to visualize, although this doesn't take into account that we actually can have multiple local RIPs here, we get stuff from all the peers, we do our best path selection, we have the RIP in a proper route server case that actually has filtering included. We have multiple of those best path selections and RIPs, and then it forwards it all to the other peers connected. Right? Right. Okay. So currently out there, at least so far, everyone has been using Quagga to have a route server. Quagga has had some trouble, let's say it like that, where, yeah, it's basically not been very well maintained lately, and it had a lot of issues with crashing bugs and things. Oh, Chris knows a lot about that.
It was never designed to scale to what we're using it for today.
Yeah, exactly. So then other options appeared, which were so far, or a couple of years ago, they were basically just open source implementations of BGP speakers that didn't really have all the capabilities that were needed to be a fully functional route server. They had the transparency, so they could just forward everything to the other node. What they didn't have was the multiple RIPs, and with that, you couldn't do any filtering on them. So within the last couple of years, OpenBGPD and BERT, Ondrej will talk about that some more later, developed all those features that are needed to be run as a route server, which put us into a spot where we suddenly had 3 options to choose from, which one would we like to use. So we have those 3, and every internet exchange, a lot of internet exchanges started testing around and trying to figure out what would be cool to use, what scales, what actually functions, what issues do they have or not. And everyone kind of started doing that on their own, until at some point we figured that it doesn't really make any sense to all do that on our own. So we decided to meet up, which is yeah. Will is in the picture too, but he wasn't actually there.
We just let him come hang out.
Yeah. He pretended to be interested in route servers too, to go out for beers with us in the evening. So we organized this week in London where Andy from LONUP, Chris from Switch and Data, myself, Mo from LINX, who works with Mike, Robert from Plix, who's not here, Sebastian from D6, who's not here either, and Wolfgang from VIX, met, and we did an insane round of testing. And I mean, we all know that putting all your energy and forces together usually makes sense, because you're kind of more focused and into it, and sitting there locked up with a group of 6-7 people without windows. Thanks, Mike, for providing the great meeting room to us that we've been able to use for that week. We played around and tried to figure out what are the limits of those boxes, how far can we go, what can we do with them, and so on. So, Chris, you continue. I've talked enough.
Are you sure?
Yeah.
Your voice is coming.
Although it's coming back.
Your voice is coming back.
I'll interrupt you. Don't worry.
I'm shorter than she is, so bear with me. Okay, so the week in London was really interesting. This week launch is Switch and Data's official launch for all of our route servers, and that trip for me was a big learning experience, as we were initially going to deploy Quagga, and that doesn't work so well. But seriously, all three of these route servers have their advantages and disadvantages. When you get right down to it, Quagga will work for you if you're not going to have a lot of routes, if you don't have a lot of ribs. Its configuration is easy. You know, BGPD has its advantages, and Bird does as well. I'll kind of walk you through a little bit of this. We used 3 labs in this testing. There's a lab in Palo Alto for switching data. We had 6 servers there running FreeBSD and Linux. We had a lab in... No, we didn't run OpenBSD. Oh, yeah, we did.
Of course we ran OpenBSD.
No, not...
No.
Oh, yeah, we did. Sorry. We ran 2 OpenBSD boxes and 4 Linux boxes. Or 4 FreeBSD boxes?
2 OpenBSD, 4 FreeBSD boxes, and we ran all the Bird and Quagga stuff on FreeBSD and OpenBGPD on OpenBSD.
Correct. And then Mo...
Can people hear me?
Yeah. Mo from LINX had a couple of boxes as well. I think they were running Linux. And Robert from Plix had several boxes and several routers in his lab in Poland that we used as well. We did a lot of the attribute testing with his systems. So, basically we wanted to know if AS4 32-bit ASN was completely functional, if it was transparent in compatibility mode, if it worked in native mode, and all 3 versions do support and through a variety of tests proved to properly pass attributes if they were running a non-32-bit ASN, or if they were running 32-bit ASN, the ASN did work properly. On V6, this is one of those ones where we were coming in that, you know, there were a lot of open bugs that had been fixed right before we got to London. And so we were really worried that there was going to be V6 problems, especially with Quagga. We had heard reports that some of the bugs that were fixed weren't fixed properly, but when we tested it, all of them do support V6 natively, support it well. I would highly advise you, if you're running pretty much any version, whether it's OpenBGPD, Quagga, or Bird, to run.
On OpenBGPD, for example, as of the summer last year, V6 actually works at all, because when we first started touching it at AMS-IX, V6 withdrawals were completely broken, and it just killed everything that was there connected to V6.
A special note at the... Oh, go ahead. Are you sure?
Yeah, sure.
Okay. You can have more time.
No.
All right. But the last bullet, ports are definitely ill-advised, because when you get into the configuration of these guys, there are configuration tweaks in the config file that you may want to make for your implementation. The ports are not super-duper good. Scalability. This is where you really start to see the difference between the 3. The base testing, with the graphs that we have here, we'll have 100 BGP sessions set up from Inixia, 500 or 1,000 prefixes, and then we generated random flaps throughout the evening and overnight while we were doing overnight testing to see what would happen as we tried to generate as close to a lab condition where we could get a large-scale internet flap over a period of time. We also did additional testing where we went to, up to 10,000, 20,000 prefixes per session to see what the scaling point, where the memory limitations, where there are memory bugs, if you went crazy in the number of routes that you were willing to give to your route server. And we'll get into that. Quagga. One of the things that when we were heading to London that we really wanted to see is OpenBGPD inherently performed better from our initial looks at it because it's multi-threaded, where Quagga is a single process. It has a session thread which will keep your sessions alive and send keep alives while the route decision thread is running. And I'll get into that when we get to OpenBGPD. But Quagga is a single thread, and it doesn't seem to have much scheduling in it. So it really, when you get a lot of updates and a lot of sessions being created, you get race conditions where it's just gone. It's a descending spiral of death once you get there. There's several bugs in this software that when you start to get into a decent amount of routes, that say 10,000 or more, and you inject flaps, or not even injecting all that many flaps, if you just, start creating more sessions, and the route decision aspect of the process starts taking over. There are bugs that will just, it runs away on the memory and you're done. So this is a CPU graph of 100 sessions with 500 prefixes on a dually 2 gigahertz Xeon box. So you see when it comes up, it seems to be okay. You get your updates from the flapping, and the CPU just stays pegged. Other than it sometimes calms down. There's no real rhyme or reason to this graph.
And it just doesn't come out of this spiral of once it establishes a session again, and it's basically busy all the time, dropping other sessions while they're in it. The spiral,
That spiral.
Yeah.
So you see a big contrast here when you get into the OpenBGPD CPU.
No, this is twice as many prefixes. Right?
Twice as many prefixes. It's a little bit. It is a quad processor box, but again, the way OpenBGPD is written, it really only needs 2 CPUs to be beneficial, and it really only is using 2 CPUs because it only has 2 threads, route decision and session. So they do get a little bit of advantage there, but if you look at the CPU graph on this thing, it's just night and day. The same flap patterns with twice the number of routes, and OpenBGPD just sits there and, yeah, what do you got for me? Bird CPU, kind of similar. It's consistent. You'll see where the flaps are generated. You take a CPU spike where the flap's generated, settles back down, and it just generally hides right around there. This CPU and the OpenBGPD CPU, the boxes were fairly close. This again is only 500 prefixes per session, but the number of prefixes didn't radically affect the CPU of Bird or OpenBGPD. It was far more affecting in Quagga. So as I've covered, the OpenBGPD is multi-threaded. The session thread is a huge advantage in OpenBGPD. It's, in my humble opinion, the strongest advantage for OpenBGPD is that you really don't have to worry about your sessions, which when you get into Quagga and you start losing sessions because you don't have keep alives anymore, you get into a race condition and your Quagga is done. Where OpenBGPD solves that by just keeping the sessions up so you don't add additional flapping because you don't have any more CPU time. The one issue that we came up with OpenBGPD, and it's actually more of an OpenBSD issue, is that we found a 1 gigabyte of memory limit per process on an i386 system. And is it 4 or is it 8?
4.
It's 4? 4 gigs on the AMD64 architecture, which, depending on how big a route server you have right now, probably not such a big deal. 2 years down the road, might be more of a big deal.
It becomes a big deal when you start configuring separate ribs for every single peer you have. If you actually have, if you have like 200 peers and everyone with its own rib, imagine that its routing table is basically multiplied 200 times, and it has to store that somewhere in memory. And we've seen situations where the memory usage goes up really, really quickly if you start using multiple ribs.
And in terms of how we did our testing, every session that was in the Ixia had its own rib. So in all these tests, there were 100 ribs created, and all the routes were advertised in and out of each rib. So it basically was 100 times or 1,000 times 100. In terms of the hash that I had to keep. So it was a pretty intensive test. I can't imagine a route server today that would reach the limitations of OpenBGPD on i386, and certainly none on AMD64. Memory usage on OpenBGPD, fairly consistent for the 1,000 prefixes at 100 sessions. it just chunked right along, even in flapping. It held its memory pretty constant. It didn't free it super fast. You can see a little bit of jitter there, but for the most part, once it's up, it's running, it just stays pretty constant. Quagga, this is where you can really start to see the difference between Quagga and the others. You get flaps, you know, it starts using memory, then all of a sudden it frees a bunch of memory, then it comes back, and then the cycle of death, and you're done. So this is a pretty typical Quagga. You saw the CPU graph earlier. You see the memory graph. This is what happens.
I've got a comment on that.
That's fine.
The other thing that we've seen in Quagga, just in our deployment as well, outside of a test, but in production, is you just slowly see memory leaking away. Yep. There's obviously some dirty ends in the code where they just leak memory as well.
There are several open bugs with Quagga right now in memory leaks. Bird. Is single-threaded. I was skeptical. I will openly admit that when we started looking at this. The single thread made me nervous just from the way that Quagga acts with its single-threaded aspect. But Ondrej and his team have done a great job with whatever scheduling system that they're using inside of the process. When sessions are coming up and the route decision process that's going on within it is being done, it won't let itself get overloaded with new sessions coming up with flaps. It'll deal with the routes and slowly but surely bring more processes up from what we could see in the lab testing. Whether or not that's how it really works, he'll tell you later. But we never had any problems with Bird in terms of, didn't matter if we threw 20,000 routes on 100 sessions with 100 ribs and had flaps occurring every 30 seconds on random intervals. It didn't matter. We could not break Bird in the lab. The most stable we had there. The only thing that we could come up with that was kind of weird in the way LINX works, I guess, is that when we ran the memory usage up and then ran the route count back down, libc won't release the memory back to the system. So it's still sitting there tied to the Bird process, even though it's unused in Bird. It's a weird Linux thing. But if you're dealing with dedicated route server boxes and the only process that's really running on these boxes is Bird, not such a big caveat for you. But this would be the memory usage on it. Again, incredibly consistent. I don't know if that's a Bird thing or a libc thing. It just gets what it wants, it holds it, and it doesn't release it. It just sits there. That's it. Doesn't matter what we did to it. It was a pretty impressive test for that software. Anybody have any questions?
And we've got time for questions now, and then also we'll have time for questions after Ondrej's presentation, and then maybe a few minutes for discussion as well, if we've got time before Berenguer. Jake.
Yes, Jake Kuhn. Speaking as a person who used to run route servers, when you did your testing, did you do it with just what was your route mix looking like when you tested?
My route what?
Your mixture.
Mixture?
What was your distribution like?
Our distribution, basically, we took and I believe that I broke it up as a certain percentage of /8s, a certain percentage of /16s, a certain percentage of /24s, and distributed it across a range of space. So I was trying to get as broad a sample as I could get without having an internet routing table replicated into the IXIA test environment.
Did you ever get close to the size of a default for each peer?
No.
What was the highest number of routes?
The highest number of routes we went to on each peer was about 50,000.
And this was Bird?
That was Bird. The one catch I would say there is that when we were at that many routes, we might not have had all 100 peers up at that moment. That was in the first week of December, so I don't remember exactly the test scenario we had, but I know that we had at one point, we had Bird up to somewhere around 500,000 routes.
Okay, and what was the memory footprint at that level?
And on Open
Pardon?
BGPD, we actually ran out of memory before we could get that far.
Yeah, we only, well, one caveat on OpenBGPD, we couldn't get that far on it, but that was because I only had a AMD or a i386 box in the lab. I don't have any AMD 64 boxes to test it on.
Okay, I'm just curious as to, in the past when we've run route servers, we've been able to get close to 100 peers with, at the time, full default-free feeds.
Remember that we're running 100 ribs as well.
Right, right. And
So
I understand that, and we also were running a rib per peer. I think the memory usage, at the time it was running on a 512 meg UltraSpark 1 box, circa 1997. But I was just wondering what how these newer route servers implement route scaling and route storage, and that you need so much more memory.
That's one of the things that I'd like to do in our next round of testing, is actually find out, based on the distribution of types of routes, so length of prefix and such, as to exactly how much space each prefix is, or if it's a prefix is a prefix is a prefix. How are the implementations hashing that and then storing it and determining kind of like a miles per gallon, bytes per route, so we could see, you know, which was more efficient, and kind of we'd have a predictable pattern for, if you're going to have 200,000 routes on this route server, this is how much memory you have. If you plan on going to 400,000 by 5 years, this is how much memory you're going to need for that. So I would love to be able to have that a little bit more granular data and actual data as to how that's implemented. But we just ran out of time.
Just a comment I want to say on the free memory thing. Don't worry about that too much. It won't free it until something else requests it.
Right.
So, you know, the reason it wasn't freeing is because nothing else needed it. You would want to look at the scan rate.
We emailed Ondrej that, like, the day after we tested it, and he's like, yeah, don't worry about it.
Yeah, you'll see it on Solaris and other stuff, too.
Were you doing the extra processing of inbound route filtering, making sure, you know, any other processing like that, or was it just accept all routes?
No, we did not do any filter testing on that. Oh, yes, we did. What the heck did we do? Did we do communities on that? Did we test communities? I don't think so. We didn't get into the filtering. The last day we were going to try to do prefix filtering, and we ran out of time. Basically, you get 6 geeks into a room, and it's a lot of fun, but everything we wanted.
5 days, and that's what you get.
We needed a couple more weeks to get everything that we really wanted to get out of it. It was interesting. Thanks, Mike, for hosting us. Anybody else have any questions? Cool.
Okay, so if there's no further questions, thanks very much, Chris and Elisa. And our next speaker is the lead architect and project coordinator for one of those root servers for Bird, and this is Ondrej Filip, who is also an exchange operator as well, and he is involved in running LINX CZ in Prague. Ondrej.
Yeah, thank you very much for the introduction. Maybe it would be a little bit confusing because he was talking about LINX CZ, which is an exchange point, but I'm working as a CEO of CZ.NIC, which is the top-level domain operator. But I'm also involved in the exchange point as well, so that's the reason I'm talking about the root server software. I'm not sure if it's a habit here to have some company introduction, but just very briefly, I didn't prepare any slides. CZ.NIC is, as I said, is a TLD operator. We are very active in DNSSEC, but more importantly, we are involved in many projects driven by internet community, and they may be related to DNSSEC, to DNS-DOL, or also to ISP and IXP business. We are hosting also some events related to the internet community. Maybe some of you attended IETF meeting in Prague. It was in 2007, and maybe some of you who are interested in European affairs plan to attend a RIPE meeting I think in 2 months in Prague, so you're welcome. But back to BERT. Chris and Elisa talked a lot about the root server part. I will introduce BERT from scratch, so how it's sorted, what are the main features, because it's a common routing daemon project. It's not just directly focused in root servers. So although you probably don't know the project, it's quite old. It started at the end of the last century, so it will become a teenager very soon. It started as a school project at the Charles University. It's almost 700 years medieval university based in Prague. And when it was a team of 3 people working on that, and as a typical student, when we finished the school project, we got grades, and we stopped contributing in that, so we didn't do anything for a while. So the project slept, and with some small exceptions, when I saw that there is something broken and needs to be fixed. But it became fully active by the end of 2008 when it became part of the CZ.NIC Labs project. CZ.NIC Labs is a research department of CZ.NIC, and they do more projects mainly related to DNSSEC, but this is one of the key projects of the laboratories. That time, and please remember it was 1999, we set up some goals, basically in a simple words, to have the best internet routing daemon in the world. And that time it seemed to be very easy because Quagga was just in the beginning. What we wanted to focus was efficiency, so we wanted to have some software or some routing daemon that is small, tiny, that is very efficient, that can be run on also devices with limited resources. We wanted to have portable and modular daemons, so you are able to add another routing protocols easily to that. We wanted to support current routing protocols at that time. And one thing that we put into the design, and which may be a little bit maybe strange, is that we wrote that code in that way that we wrote both IPv4 and IPv6 implementation in once. So it means that if you want to have an IPv4 daemon, you just compile it. If you want to have IPv6 daemon support that supports IPv6, you compile it with compile option enable IPv6. So IPv4 and IPv6 implementation is in a single source code. So what is the current status, or what the main features does it have now? It's very portable, but honestly, the only operating system that people requested were Linux and all variants of BSDs. It supports IPv4, IPv6, of course. Of course, it supports static routing, how surprising. And then all those 3 major routing protocols, probably not very used RIP, but in all these variants, version 2 and next generation, we have both OSPFs, version 2, version 3, and of course BGP. There's some more features that are related to those protocols, but I believe you can watch the web pages to go for further details. It implements BGP root reflector, and what is most important for this track is the root server. We support 32-bit ASNs and MD5 authentication and many other BGP-related things. And also you can of course dump the messages you're receiving, and etc. What's maybe different from the others? We support multiple routing tables, multiple RIPs, but in a little bit different way than the others. You can also synchronize those routing tables with operating system's kernel. It's just implemented on Linux, but if you have operating system that supports multiple routing tables, you can synchronize them independently with BERT. One very special feature, which I will talk later, is protocol pipe. It's a protocol designed to interconnect two routing tables, and those routing tables became synchronized, but some filters may be applied in the process. That means that BERT can be used and is designed to work as multiple routers, router factors on a single system. So you may run more instances of BGP protocol, SPF protocol on a single machine, and you can really freely decide how you want to synchronize the routing tables among those protocols. We believe we have very powerful configuration, although it's probably very different from the current ones. It a little bit looks like a programming language. We have very powerful filter language. I will discuss that further later. And we have a command line interface that's probably also not shocking to you. But the problem is the configuration, the way it's done, it can be set up or changed on command line. So the command line interface serves just for the showing routes, showing protocol, showing states of the routing daemon. You can also, of course, restart or disable some instance of some protocol, but you cannot configure it from the command line interface. You can just load a new configuration. And that brings me to a very important feature for root servers and such stuff. It's the automatic reconfiguration. BERT goes through a configuration file. It is able to find differences between the new and old version, and then it reconfigures just the parts that are that has been changed. So, for example, if you add a protocol, it just starts a new protocol and it doesn't affect the other instances, etc. So even if it's not configured from command line, it is able to see the differences and automatically just restart the effective instances of routing protocols. So that's a simple schema how BERT can be configured, but as I said, the possibilities are almost unlimited in that. Perfect. This is, for example, a typical routing demo, as can be, for example, Quagga, very easily configured. You have BGP, OSPF, some static routes in that. That everything is connected to a single routing table, and then it's synchronized to kernel, to operating systems routing table. The difference, what can be done by BERT, is that we add also the pipe protocol, so you can have a separate routing table with a separate instances of routing protocols, and those can be somehow synchronized. And you can build a very complicated network inside the single BERT process. So that's something that makes BERT very configurable. And in all those stages, you can see you can apply filters somehow. So now, how the configuration looks, what's the philosophy? It has multiple sections, but there is no fixed order in what you have to configure it. But of course, there are some commands related generally to the daemon, like where do you send the logs, what's the router ID, etc. There are some protocol sections that defines instances of various protocol, and it's like his example of static routing and BGP. And there are also filters which can be freely written everywhere. And as you see, the filter language really looks like a programming language. So you can have if, then statements. You can have case. We do not support cycles, but the language of the configuration is really broad and rich. The command line interface, as I said, it's not probably very complicated. There are a lot of show commands. You can list protocols, show the status of the daemon, and so on. You can, of course, list the routing table. Important thing, the routing table is able to not just carry the most optimal route, but a lot of others, which is widely used in root servers. Again, probably for you as a networking guys, nothing surprising. You can list the routing table, or you can list specific routing table. As I said, you can have more of them. You can list specific protocols that what routes it added to the routing table. And there is a little bit more. You can look for a route for a specific IP number, so you see what route applies to such IP number. You can also look to the routing table and apply some filter. That's very handy, especially if you look for some specific information very often. So you can, in configuration, predefine your own filter, and then you can use that filter for looking into the routing table. Another thing is you can look at the routes that are exported to some protocol. And on the last two lines, there are two examples. They do the same, actually, but it's just to show you how complicated it may be, and complicated also means powerful in that case. How powerful may be the command line if you want to look for some information. So you can see what routes include the specific IP number, which is this line is a little bit simpler, but you can use much more complicated, which is the last line. So you can write the whole language of filters into the command line to be able to pick up some specific information you need. And now I will start with the root server part, but it's still about BERT generally. But I prepared an example of a filter that is widely used in root servers. On the screen you can see the root server policy that this is specifically about NIC CZ, about the Prague Internet Exchange, but generally this is the common of the best practice for many IXPs. So by sending communities, BGP communities, you signal to what peers you want to export your routers or not. So probably you know that scheme in your Internet Exchange. And if you want to configure or if you want to apply this routing policy to, for example, Quagga, it's very low configuration with a lot of lines, because you need to type specific lines for every BGP instance, for every BGP peer. But implementation in BERT is very simple, because we have a very, as I said, rich filtering language. So the implementation of that policy is just those 8 lines in the middle part. The rest is just another BGP instance. So we may use defines, which is nice. You don't have to repeat all numbers that you are later not aware what they are from. And more importantly, we can use variables in filters or in functions. So as you see, the BGP instance just calls that function, and then it directly knows, and it's applied as a filter, so it decides whether the route is exported to another instance or not. So that's to see the power of the filters. Another good thing is we don't have just comparison of 2 values. We can also look at the member of a set or member of a set, and it can be a list or set of prefixes. It can be a set of autonomous systems. So, for example, this is how to avoid some networks you probably don't want to import. And the beauty of that configuration and the beauty of this approach is that it's not line-by-line configuration, but we can compile it in advance. So from this set of prefixes, we built a binary tree. So the computing complexity of that filter is not linear, as in the other daemons like Quagga or OpenBGPD, but it's logarithmic, so it's much faster, especially if you have very large set of AS numbers or prefixes you want to filter. So that's very handy, especially for root servers. And again, if net statement, the same for AS numbers, just with the difference that you can also have ranges of numbers. I'm not sure if it's really useful in that case, but that's also one possibility. And again, we built a binary tree, so the search time in such a list is very, very fast, and the computing complexity is very, very low. And really, there are root servers and there are peers that have thousands of AS numbers, and some IXPs filter them precisely, so that's handy. And another and last example from the filter language is the case statement. This actually looks at the originator of the root, who is the last in the BGP path. And again, it's also implemented by binary search tree, so it's also very fast. And this is very useful, for example, if you very precisely filter AS number and its prefixes, you want to control that everything was written in the root database is also announced by BGP. Some IXP do this, and without the binarities, it would take a lot of computing power on the root server, and it takes a lot of computing with Quagga, for example. So now let's switch to the root servers. I prepared for you some sort of scheme how a root server may look with BERT. I say may because some people use different approaches, but this is how the majority of IXPs look at the configuration of root servers with BERT. So what you see on the picture is that you have routing tables that are the blue circles, routing tables, blue circles for every AS number, every peering AS number. As these AS number may have more peers, more IP addresses, those are the green, I don't know, the green stuff. They are connected all to a single routing table. We don't apply filters at that stage, so we see exactly what those people are sending us. But those routing tables, those local routing tables, are connected by pipe protocols to the master routing table, and the whole filtering is applied in the pipe protocols, in the, I don't know, it's purple or red colored things. So you see everything it's announced to you. You filter just those prefixes that are okay according to the described policy in the database, RADB or whatever you use. And in the master table, then you apply again exporting filters, so you export everything back to the local routing tables. So that means that with the number of AS numbers, you multiply the memory consumption for every AS number, but on the other hand, you have full control of what is everybody announcing to you. You see what routes comes to the master and what are exported back by applying the routing policy, as I described later. So this is typical scheme how this is built. And now to the concrete implementation. The first implementation of BERT as a root server was done at LONAP. Those guys were very brave and helped us a lot with debugging or with adding some features that are necessary for root server. As far as I know, they run two root servers. One is BERT and one is OpenBGPD. And they run it for, I don't know, 1,000 prefixes that date. I don't know what's the current status. But I recommend, and this is, I think, something I usually recommend. Every software has a bug, so don't stay just with one root server. you should have at least two, and it's handy and it's good if you can have multiple implementations, because if you have just two but the same ones, they usually crash at the same moment, so that's not very helpful. The second implementation was at NIC CZ. Surprisingly, the setup is the same. We run BERT on Linux and Quagga, still Quagga on FreeBSD. Our experience is that, or NIC CZ experience is that BERT's not crashing since the release. We have approximately 6,000 IPv4 prefixes, and the memory consumption is quite low, much lower than Quagga. Another one, this is a little bit different, so that's why I'm picking it up. It's VIX, the Vienna Internet Exchange. They also use BERT, but they decided to have a little bit maybe strange, or let's say different schema of the pipe protocols. As maybe you remember, I said every BGP instance is connected to some local routing table, and that's connected by pipe protocol to master routing table. What VIX does is that they use pipe protocol for connecting every routing table with each other. So they have, n times n pipe protocols involved in that. That's also a possibility. As I said, it's very modular and configurable, so you can do whatever you want with that. So seems to be working for them, and they have currently 12 peers in the testing. Another one is LINX. They started last month, and after long and careful testing, they replaced Quagga with BERT, and as far as I understood the messages from them, they seem to be satisfied with that. They have about 40,000 IPv4 prefixes with about 200 BGP sessions, so it's quite saturated. As I said, they do a lot of testing, but I think after the presentation that Chris and Elisa did, it's quite useless to show you those graphs. As it was said, BERT is very, let's say, conservative in the memory consumption. It consumes just really needed memory, however, it's almost never released the memory. The idea is that if it's a routing daemon or a root server, it probably will, if you have enough memory, so why not consume it? And you will probably need it next time, for example, if just some peer flaps and it's not very good to release memory and then take it back. For the stability, it's much better to keep those memory and be ready for reusing it. So this is how memory consumption looks at LINX. You can see it's stable. And of course, when some announcement comes, the CPU has to work. There are several other applications like switch and data. They started using as a root server. I don't have any details about that because I thought Chris would speak about that. Maybe you want to comment it?
We have two peers on Palo Alto, but we were using for our beta just to make sure that we were good to go. But we'll start publicly allowing customers to go on the route servers. At all of our markets, we launched 14 route servers. So good to go. And we like BERT.
Thanks. And also the Moscow Internet Exchange is running this as one of its root servers. Another application is we use it as AS112 Anycast instance at NIC CZ. I know that some small ISPs or some home users use it as a BGP or OSPF router. CZ.NIC as a DNS operator uses it for Anycast nodes. We deployed Anycast clouds, well, we can say worldwide, and we use BERT for for any casting or DNS servers. In the beginning, I said we were focused on the low resource consumption, and that's probably the reason that BERT is used by some small Wi-Fi access points and such small devices, because they like the fact that it's not consuming too much resources. And some other IXPs are planning to implement BERT as a root server, or at least testing it. We are in touch with JPNAP, and DKIX announced that they will start BERT as a root server, I think tomorrow at midnight, this local time. So it's Wednesday morning, European time. So also DKIX is planning to run BERT soon. And you know, it was, I think, partially said, it's part of EuroX activity, of EuroX project, having at least 3 good implementations of root server live. So I hope BERT is one of them. We did some small tests, but we were quite careful doing those, because it's much better if some third-party people do testing instead of you. So we just prepared a simple test about the memory and CPU consumption in a single BGP router that just loads the whole BGP table, and that's all. So we measured the memory consumption and the CPU time, but not the real time, but what operating systems declared that CPU time was. We tested Quagga and OpenBGPD, but we did it on Linux, and I know it's not fair, because OpenBGPD is not really designed to run on Linux, so it may have some problems. We did 2 tests. First one was to start up such router with synchronization with the operating system's routing table. And OpenBGP didn't work in that scenario, because, as I said, it's not Linux-focused project, so we couldn't use it. But anyway, it was a simple test, but you can see the memory consumption is, I don't know, 6 times smaller compared to Quagga, and the CPU time is 10 times more. Quagga had two processes, Quagga and Zebra, for the synchronization with operating systems routing table. The second test was done without that, so Quagga lost one of the daemon, one of the process, and as you see, the memory consumption of the BGPD process remains almost the same. Also, the CPU time was much shorter. BERT's memory consumption is the same. There is no reason to change. But of course, the CPU time, because we didn't have to synchronize with operating systems routing table, that's much shorter. And BGPD, it ran 2 daemons, and as you can see, OpenBGPD is in this special scenario quite comparable with BERT, so that was quite okay.
Ondrej?
One thing. Go ahead. Go.
I would definitely not recommend using a very old OpenBGPD version on a Linux system, because
I agree.
They made so many changes to that in the recent times that it doesn't.
I agree. Okay.
Yeah.
I'm close to the end. So the future development, or what do we plan, except having more implementations by more and more exchange points? You can see we do about monthly releases. We would like to work on some improvements in OSPF, like opaque LSAs and such stuff. Because BERT is used by really tiny or embedded systems, those people requested to have really lightweight command line interface, because they even don't have some Unix, standard Unix libraries like libhistory or such, so they really need very lightweight command line interface for that. We still don't have a root flap dampening, so we will work on that. But the main message is that all development or all future developments really depends on the user demand. So if you are missing some feature in Bird, just don't hesitate to write us. On the web pages, you can see the user's mailing list. So just join and write us whatever you want. We are very open to that. So the summary. I think Bird has a powerful and configuration filter language. It's lightweight and very efficient routing daemon. It's developed by people from the IXP community, and I hope we can say we are quite active. One problem is that we have unusual configuration language, but maybe you understand now why it's really necessary if you want to do very efficient filtering. Maybe we are still missing some feature. For example, we never implemented ISIS or such routing protocols. One thing that may be strange for you is that separation of IPv4 and IPv6 instances. And last, I put a question mark there, is that single thread application. But really, instead of talking about single or multi-thread, it's better to start testing, look at the performance of the daemon, and maybe you will see that there is no real need for multi-threading, because the performance that multi-threading may add to the design that Bird has is a little bit, it's a question actually. So, because you would have to implement a lot of locking and other stuff that you don't do in a single thread, and maybe the gain of that wouldn't be so nice. So that's all. If you need some more information, look at the web pages, which are bird.network.cz and not .com, like you are used, guys. And thank you very much. Any questions?
The one thing I will say is that in dealing with Ondrej and the team from Bird, they are incredibly fast to respond to bugs, issues, features, whatever. They have a dedicated team working on it. I email these guys, and 5 minutes later, we got a bug fix. It's awesome.
John Kemp for Route Views. One issue we have is when we're writing out ribs. So every 2 hours, we dump the entire rib. And I wondered if that was ever looked at as a possible performance issue for Bird.
You mean you explore the routing table, or?
We write it to disk. So.
I think the best way is to let's come together and try it. I don't think it should be a problem. Well, I don't see any issue that could we have in that. The routing table export, or if you just want to export routing table to the disk, is done. It just takes the CPU time that is not used by the routing instances, so it shouldn't, make the system slower. It should work. But really, probably the best way is to try it, and we will see what issues we can have with that.
And one general question. For feedback for the Quagga people, what is the programming method you're using that you think gives you the better performance than Quagga? I sort of understand how they're doing their threading, and they give access to a thread, and that thread can just hold the CPU. Mm-hmm. I assume you guys are doing something that's more event-driven?
Yes, exactly.
In a route server, events drive the CPU. You get flaps, there's your event that's driving your CPU. And in general, in Quagga, it's not only just that you have event CPU issues that drive the CPU. You also have memory issues in terms of the fact that while an event's going on, that thread within the process will just grab the memory, go off crazy, and you're done. And it has general memory leaks. Even if you leave it stagnant, you'll still see your memory continue to erode. So there's several problems there.
Ondrej, have you got any specific comments to make on the programming technique that may be different to Quagga, or why it's more efficient?
I think the main difference is the design. We were not tied with any configuration language. We designed everything on a green field, and that's the main difference. The design is completely different. And also to the event, I think every routing daemon has to be event-driven, because if there are no other announcement of prefixes, there is really no much work to do as a routing daemon. So you anyway wait for some external events or events caused by timers. But yeah, that's all.
Can I make a comment on that as well? Just from our experience with Quagga was, obviously everything goes into this work queue, and that's pretty much processed in order. And things like even the BGP session control is sat in the work queue along with withdrawals and insertions and everything else. So the whole thing just, you would end up with basically things going into a race condition, followed by basically just spiraling death, because you missed the keep alive. So then you ended up with another 10,000 withdrawals to process. So that was really one of the blocking issues on Quagga particularly, was just the session maintenance was done as part of the main thread and not scheduled sensibly. Jay?
Hi, Jay Kuhn. This is more of a question to the operators, and I'm just wondering, well, as you probably know, running the route servers and managing the sessions for the peers is pretty much the most difficult portion in the whole route server game. Because the dirty little secret is that you have to negotiate and set up all these pairwise bilateral peering sessions within the route server itself. What steps have you taken to automate and manage that management piece? And also, there's a couple of things that we found when we were running route servers at Merit that were side effects and value-added benefits. And could you maybe expound upon what you're doing to use the route servers as a way to help your user community? For instance, one thing that we provided was the ability to monitor peering sessions for all the peers.
Okay. At Switching Data, our implementation is completely automated, so we don't actually have our people logging into the route servers themselves. We have a provisioning database that maintains the AS set, and IP address for all the customers. When they want to activate their route server session, they email the NOC, give them the AS set. We already know their ASN and their IP address. They plug the AS set in, it goes out, walks the IR, gets all their routes. Thanks, Raz, for that, by the way. Gets all their routes. We build a prefix list per peer and set the session up as a passive session. So
are you configuring automatically, and what's the time schedule on that?
We update every route server's config about every 5 minutes.
Wow, really?
Yeah.
Wow. So pretty much same for AMS-IX. We have a database in which we basically just take, he wants to peer with the route server, and it fetches all the data out of the database. And we get the AS set for the filtering. We base our filtering on import-export rules in the AS sets, and it fetches that automatically for a newly added peer, and then it redoes it every 6 hours for basically filtering changes or something like that might have happened in the database.
And for the bird developer, or the operators, what tools are you using to generate the bird configs?
We wrote our own scripts in-house to do that. In my opinion, there's not really a good, for bird in particular, there's not really a good automated config generator. You're pretty much going to have to figure out the way. We only use prefix lists, and some exchanges use prefix list and communities. Some only use communities. So it's really going to be specific to the way that you're doing it and how you're seeing, like at the VIX, the way that they do ribs is different than the way that AMS-IX does ribs, and we only use one rib. So when you get into that and you're starting to pipe between different tables and such, the config is going to be radically different for each exchange. The biggest config we were talking about earlier was about 4 megs. Our biggest one at Switching Data is about 1.5 meg.
Oh, actually, it's bigger. It's 11 megs.
Oh, 11 megs? Okay. So you see the size changes significantly, and you get in. 1 second. When you get into configs that are this large on such a wide deployment, there's no way that you can do this manually. Absolutely not. It has to be automated.
And it all depends on how you do your filtering in the end, because configuring a couple of neighbors, that's a couple of lines, and it's all the same all the time. And if you have the IP address somewhere, you can write that in 3 lines, right? So the filtering thing is the thing that matters the most for automation. And we don't do any prefix filtering. We only filter on which ASs people would like to import and export to. So our config is fairly small.
I just wonder, there's no general tool for making the configuration. I know that every IXP has its homegrown system, usually some parallel or another scripting language that takes care of that. And it's usually taken from the routing database like RIPEDB or ArrayDB and such.
The flexibility that Bird's configuration language offers leads to widespread configuration variance. Where Quagga is very Cisco-like, you have a very fixed style of configuration. It's easier to generate configs from a tool, where in this language you have so many, because you have different ribs and pipes and communities, no communities, prefix, no prefix. If you took let's say 8 IXPs that I know of that are either using Bird or going towards Bird, and you looked at their config, every one of them is going to be probably significantly different from every other one. No.
Just from a LINX point of view, yeah, we generate all our config with our own homegrown scripts that are basically quite tightly integrated with our back-end provisioning database as well. So when it was written to do a job rather than to be portable. So it's not been written to be abstracted into other environments.
Yeah, we at NIC CZ, if I can speak on behalf of NIC CZ, we generate also configs based on the prefix list and AS number list, and we do it automatically every, 6 hours.
And for those exchange point operators who are looking to possibly run route servers and may want a more, shall we say, pre-canned solution, have you thought about talking to or respinning some of the efforts that were done with IRR toolset, for instance? I mean, when we ran route servers at Merit, we used RA toolset, which became IRR toolset, and did our automatic configs that way. But obviously, as you said, Bird's configuration is much more sophisticated and flexible. However, I can imagine that there might be some pre-canned solution that might be at least available for those who want to quickly start up and get a route server running.
I would offer you 2 suggestions in that. There are things out there. Aaron Hughes has written a great peering tool that we use pieces of that as part of our glue. IRR PT is great. We use that to generate V4 prefix lists. So yeah, there are canned stuff that goes into it, but once you get down to your base implementation, when we really started looking seriously at rolling Bird, honestly, the other IXPs were our best resource, and Ondrej. We really reached out to the other IXPs, AMS-IX, LINX, and at LoanApp, and asked them for how they did it, how their config looked, and what are the gotchas, and we went down that road. I've found that pretty much every IXP that I've talked to is very willing to share not only config versions, how to set it up, what glue that they used, if they had anything that was being generated from an existing tool. I have no problem sharing how we put our glue together to do it. I know pretty much everybody that I've talked to has been willing to do it. So if you're looking to go down that road to set up a Bird version of a route server, your best resources are Ondrej and the other IXP operators. Get on the Bird mailing list. It's not high traffic, but the questions are usually really good.
Thank you.
You're welcome.
Hi, Brian LaCroix from Yahoo. Guess I have a comment and a question. From a comment perspective, I'd like to thank you for all the time that you've put into route servers. It does make it much easier for us that are turning up and trying to tear down and maintain the sessions with the people that come in and leave the peering fabric. So thank you. And a question, if in your conversations with your customers, or in fact with other operators in the room, in the scenario where you may have a path to a particular network via both a public peering fabric, via a route server, and via a private peering session that you have a cross-connect between cages. How are people preferring that they use, or are they not preferring which path to take? My personal opinion, I like to, if I'm, have a private dedicated connection between me and somebody else, I would prefer to use that, but kind of curious how your customers are seeing that. And
honestly, I have no idea, but I would instinctively say that I would do the same as you, prefer my private connection to them and then use the route server as a backup. And it transparently forwards everything else if you want to set any prefs or something on it. So you can basically set it up as you like for which one you would like to choose first.
I've just got a quick comment about how people are doing the path selection. Where they've got a PNI in place, they tend to just have direct peering over that PNI and local pref routes learned via that. That tends to be a common hack to go and do that. So rather than trying to work it out over the root servers, obviously you wouldn't. In theory, anything that you learn over the root servers should have a next hop on the shared medium as well. It shouldn't have a next hop somewhere else.
Yeah, correct. And we've had some conversations internally where it's really nice to have the two paths. It's just do we choose to use a dedicated path, and then on the reverse path, how do we control that person on the other side where we don't necessarily own their route, or do we do adding additional prepend to a route server or what have you? And have you actually considered just slapping a prepend on everybody coming in with their AS on the inbound? Would that address the issue globally without having to make any special configs for all the customers?
I would think that exchanges that accept communities, that if they allow you to change local pref, that wouldn't work. You could just no export them to that peer over the shared medium, and just only accept them on the PNI.
Will Hargrave from LONAP here. Just wanted to make an observation on that. This isn't really a new problem. We certainly in London we have lots of people with multiple sessions, and they're on the root servers. They've got cables. They've got all kinds of stuff, and but actually local pref is kind of generally too big a hammer for this kind of manipulation, and people do more complicated things.
I've seen it a lot though.
Yeah, it's caused a lot of problems as well. If you look at interesting problems.
Okay, so we've had a bit of a discussion as well. So I was going to say, do you want any more, a general discussion? But I think we've kind of had that. And I keep seeing lots of comments on IRC that people keep saying they can smell barbecue, which kind of means the food might be ready. So I think, unless there's any, you guys have got any closing comments, just go along the line there. Chris, have you got anything else to say?
No.
Elisa, how's your voice? Is that back or gone? You're hiding, okay. And Ondrej, have you got any further comments or finished? Okay. Right, so I'll stand up to finish the, oh, that's loud. Okay. Right, so yeah, beer and gear now, that's on this floor, but I think it might be either that way or that way, but probably that way. On this floor, and there's a social this evening, so once the beer and gear's finished, Data Foundry and Giganews are going to go and buy you some beer down the road. There's flyers and stuff that tell you how to get there, but it's basically just straight down 4th Street, kind of that way, I think it is. But there's flyers and stuff, and you've got the addresses on the back of your badge. So I'd like to just thank Ondrej, Elisa and Chris for the hard work that they put into the presentations, and also Ondrej and his team for the hard work that they've actually put into the programming as well. It's great to actually have a need answered, speaking as an operator of this stuff. I hope you found this useful, and just show your thanks to the presenters in a custom way.